All right, practice problem 511, millimeters, grams, and seconds. Part origin is at the front center, so we're going to be drawing geometry in the front plane, and the origin at the top. Lines, center lines, rectangles, arcs, circles, extrude boss, extrude cut. The angle plane, create a plane on an angle through the front edge and cut with a circle. So the reason that they're spelling out cut with a circle is because, and the plane is because there is a way to set an angle, but it'll make this more elliptical than cylindrical. The other thing I noticed is this really looks like tapped holes, the cosmetic threads around the holes. So if there is a variation from the 208.19, we'll go back and check that out. 23 for the cylinder radius, 25 on the angle. So we will have to kind of adjust our plane that goes through that front edge to make sure that we're getting to the 65 degrees, the adjacent angle, or the 25 if we can, depending on what we select. So those are the issues that jump out that we may need to resolve. So new part millimeter, front plane sketch. If we are going to mirror, then let's go ahead with the center line, vertical infinite length. And we'll just go ahead with a midpoint line and bring that out. And then we can just escape and go back into the line. All right, it comes down a little bit, it goes back, and then we can continue the tangent. Probably could have just gone ahead and drawn that out. It would have been about as easy. So select, control select, mirror the entities, join the two ends, make sure you have tangency. All right, and the last piece of geometry will be the circle. All right, so the width then goes to 88 and 24 on the height and 40 to the center of the circle. And if we inferred that coincident, then this arc moves with it. So radius of 25 and diameter of 19. All right, so pretty straightforward on the geometry. Like I said, we could have just gone ahead and drawn around. Mirror didn't add that much to it, but didn't help, but it didn't hurt either. So extrude. We're going to reverse the direction, make sure that our end condition is blind, and go to 12 millimeters. All right, so on the right plane, bisecting the part, we can open up a sketch. And if we included all of this, it wouldn't hurt, wouldn't help. Again, we can go to the back of that feature and it will merge the entities. And we're just going to rough sketch that shape in. And we have for our distances, so again, stay with that right click and the dimension. You can always come up to the cosmetic thread, but that's moving the mouse all the way over there. And well, while that works, we're trying to be a little more efficient. All right, so the height then, we have the 6 millimeters, the 35. Am I missing something? So I don't think that one went through. Don't think it was at the 24. So possibly a missing dimension. And I'm not seeing it. I'm still not seeing it. So we're going to move on with a 20. So I think maybe that if there's an issue, that will be it. So I'm not really going to chase the volume on this one without having with a missing dimension. So 110 on the overall. So again, this edge can be projected into the sketch plane. We can use that for our overall dimension. And yeah, it looks about right, maybe 19. Anyway, we're going to extrude out, and we can go up to vertex in direction 1, and then we'll go direction 2, up to vertex, and we're just picking those corner points, those intersecting points, so that it has the end condition to bring it to that geometry. All right, so we'll save the angle for last. Let's go into the hole wizard because I do want to see the difference between the thread. All right, so if we pick a hole diameter and it's called out as a diameter of 10, we're not given any indication that that is actually a tapped hole. Then we're going to scroll down to 10. Okay, and its end condition is going to be through all. And the positions then, since we already selected, if it asks you to select, then you're just going to select that top face. If you've pre-selected, then it just jumps right into, my center line. It jumps right into that that face and is ready to go. All right, so center line from origin to midpoint. The two circles will be vertical in our select control select. They remain selected. They're still in the selection color, so I can come right over and select the center line and mirror the entities. Now we're ready for dimensions. All right, so between those we have 35, and from the edge we have 15, and then between horizontally we have 55. Okay, so that gives me the whole location. Now we're to the part that we need to set up the plane. So I'm not going to pre-select anything. The first reference is that top, and the second reference is the front edge. So if I go back and I identify the angle, then we go to the 25 degrees and we click into the work area. That doesn't look like it's going to help. Neither one of those looks like it's going to help. So we're going to come back to the adjacent angle and go 90 minus, and click in that area. Or if we wanted to stay with the 25, we can always clear the selection or delete. I could also reselect the face and switch over to the front. All right, so that is actually the direction I want to go because the cut goes that way, but we'll just check the flip offset to make sure. All right, so once we've gone through the gyrations to create the plane, it's still highlighted, so we should be able to go into the sketch, and our circle is showing the cylinder radius at 23, so we can go to a 46, and if I escape out of the dimension, then it's just a left click and select the radius to verify. All right, so let's see what that looks like if I go back to the isometric view. All right, so that's kind of leaned in. If I hide, all right, we go back and hide the plane, then we can see where that that cut starts. So that's only going to go in the extrude cut. Right now it's set to through all both, but if it had been a blind in condition or an up to next, then it would have stopped at that first. Would have left a little fingernail there, or would have only taken the fingernail out of the front. All right, so let's see what we actually got for. We had the 208, 819, and I'm off by quite a bit. All right, so missing dimension and the geometry and probably the threaded holes. So that one we're not going to worry about, but I am going to make my, oh, I guess there is one more that, well, actually that would take more material, wouldn't it? I forgot the radiuses. So the corner radiuses are 5, and so we can do that with our fillet feature and go to 5 millimeters. And we were at 175, so how much did 175.408? So it took a little bit more. Okay, so the fillets go in last anyway. It shouldn't have any effect with those. Let's go ahead and edit the hole wizard because I do want to see what it looks like as a threaded M10. And even though that will add some material back in, I don't think it's going to be enough. Really, that missing dimension there is the one that's going to give me fit. So 176 added a little bit more material back into that geometry. So let's see, I was just going to check. I know that the cosmetic thread went to, oh, I'm not getting cosmetic threads. Why not? All right, I will have to look into that. I'm expecting to see the little dash lines, and I'm not getting that. So, yeah, while we're here, let's just check. Oh, it is for whatever defaulted to the tap drill diameter. Very, very rarely will you go to the major diameter and remove the thread. We actually want to add the cosmetic thread, and we don't really need a class of fit or the thread call out. We'll go ahead and put that in. And then if you are in the ANSI standard, you will get the dash, and the ISO is about 3/4 of the way around depending on the size of the hole. Okay, so after all of that, what I wanted to include in this discussion then is if I suppress the cut, and let's go into the right plane. And again, this is just an example. So we're going to pick a point along this edge, and that was the 25 degrees. That's going to just give us a reference. So I'm going to go alternate interior on that shape, and that just gives us a direction. So if I go into a sketch on the front and we do the same circle, the other thing with the circle is the arc may not fully cut, as a tool may leave geometry somewhere. So using the circle and having it create that shape. Oh, I didn't really need to get out of that. But let's go ahead with making sure that it does a complete cut. So notice how this is flat. Then when I go in to do the extrude cut, we have this little thing that is the direction of cut. And let me see if the tooltip will come back up. So the direction of the extrusion, always kind of thought of it as a vector. We'll shift that around, but it's kind of hard to tell the difference. Maybe we would be able to measure. The one tool, though, that does is we have zebra stripes, and we have, see if we can find those. All right, so the zebra stripes, that doesn't give us a whole lot of information. Usually we would see the disconnect going from like that surface to that surface. So zebra stripes don't really help there, but the curvature, all right, so that's a consistent radius of curvature. And let's then see what, so this should be more elliptical. So I'm not, that curvature is changing. So 45, 40, 40, 52. All right, so the curvature should be constant for a cylindrical surface. So if I suppress that one and unsuppress that one, and we go back and we pick up that same curvature, then that number doesn't change. 0.0434 everywhere I go, it is the same because that is cylindrical where the other one is slightly elliptical. But there are times where this method is handy. There are reasons that we might want to do that, but just know both techniques and the capabilities of each strategy.